Let us try to find the GCF and LCM of these two numbers using continuous division method, or what we know as the ladder method. Okay, the first thing that we should do is to think of a prime number that is divisible by both these numbers. Using the divisibility rules, since these numbers are even numbers, we can use 2. 2 is a prime number, okay? And then divide both these numbers by 2. 16 divided by 2 is 8. And 28 divided by 2 is 14. Okay, we will just continue the process until none of these numbers have no common factors anymore. Okay, so let us use again 2. Since they are even numbers, 8 divided by 2, that's 4. 14 divided by 2, that's 7. Since the quotients are 4 and 7, which have no common factors anymore except 1, so we can now get the GCF of 16 and 28, which is 2 and 2. So we're going to multiply 2 times 2, that is 4. So 4 is the GCF of 16 and 28. In finding the LCM, we can just continue the process. Okay, so since these quotients here are 4 and 7, since 7 is already a prime number, so we will make also this quotient for a prime one. How? By dividing again by a prime number. So 4 divided by 2, that is 2. And then just bring down 7, since we cannot divide 7 by 2. Okay? So, as you can see, all the numbers here are prime numbers. So, this is now our LCM. So, our LCM is 112. Okay, so for our next example, let's have these numbers: 18, 24, and 36. Again, the same process. Think of a prime number that is divisible by all these numbers. So we can think of 2 again, since they are all even numbers. 18 divided by 2, that's 9. 24 divided by 2, that's 12. And 36 divided by 2 is 18. Okay, now think of another prime number that is divisible by all these 3 numbers. We can use 3. Okay, since they are all divisible by 3. 9 divided by 3, it's 3. 12 divided by 3, it's 4. And 18 divided by 3, it's 6. Okay, now, can we think of another prime number that is divisible by 3, 4, and 6, except 1? Okay, so they have no common factors anymore. So our GCF is 2 times 3 is equal to 6. Very good. Now, for the LCM, we have to continue the process, even though they don't have common factors anymore. Because as you can see, we have 4 and 6, which are not yet prime numbers. Okay, so we will continue dividing. We can use 3, since we have 3 and 6. 3 divided by 3, that's 1. 4 divided by 3 cannot be, so just bring down 4. And 6 divided by 3, that's 2. We still have 4, which is not yet a prime number. So we will divide it by 2. 1 divided by 2 cannot be, so bring down 1. 4 divided by 2, that's 2. And 2 divided by 2, that's 1. Okay, I guess we should stop here. Now, the LCM for these 3 numbers, including the GCF, are these numbers here. So we will arrange the numbers from least to greatest. So how many 2s are there? So we have 3, okay, times 2. And then times 3 times 3. Or we can just use exponent for this. 2 cubed times 3 squared. Okay, the answer for this is, that is 8 times 9. So the LCM is now 72. Another example, I will give you 4 set of numbers, or 4 numbers. Okay, we will find this, we will find their GCF and LCM again. So we have 21, 28, 35, and 49. Now, think of a prime number that is divisible by all these numbers. So we can use 7. 21 divided by 7 is 3. 28 divided by 7, it's 4. And then 35 divided by 7, it's 5. And 49 divided by 7 is 7. Now, can we think of another prime number that is divisible by 3, 4, 5, and 7? Okay, so there's no more common number or factor that is divisible by all these numbers. So now, our GCF is only 7. Okay, for our LCM, we will divide 4, since this is not yet a prime number. So we will divide it by 2. So 3 divided by 2 cannot be. 4 divided by 2, that's 2. 5 divided by 2, that's 5, cannot be. 7 divided by 2 cannot be. So bring down 7. So I guess all these numbers here are all prime numbers. Now, we will all multiply these numbers to get our LCM. Again, we will arrange the numbers from least to greatest. So there are 2 2s times 3 times 5 times 7. And there are 2 7 here. So using the exponent, that is 2 squared times 3 times 5 times 7 squared. So we have 2 squared is 4 times 15. 3 times 5 is 15 times 7 squared is 49. Now you need to solve all these numbers since they're too big for you. So the answer, or the LCM, is 2,940.